So, happy Halloween, everybody. Thank you for making it on a Friday morning. My name is Bob, by the way. You just call me Bob. And I'm going to give a few lectures for the next few weeks in the software engineering. Well, I call it software engineering by accident, even though the module is officially called developing maintainable software. But I will call it software engineering by accident sometimes. I think of this as software engineering part 2. That's what I would call it if I was in charge of the naming conventions. Does anyone have any questions before we get started? Question?
Do you need to watch the pre-recorded lectures to understand this?
That is an excellent question. There's some Halloween candy for everybody to ask. The question was, do we have to watch the pre-recorded lectures? So I was hoping that everybody would watch the pre-recorded lectures, but I checked this morning and most people didn't. I can see how many people watched the lectures. So the plan today is I was originally just going to assume that everybody watched the pre-recorded lectures and continue on, but I changed my mind. I'm going to start with the beginning of object-oriented methodology, which is objects and responsibilities, and try to do a condensed version of that lecture that only requires one 50-minute session. That's what I was going to attempt today, rather than just going straight to the next chapter or whatever, the next topic, which is collaborations. Any other questions? I brought some Halloween candy with me today, by the way. Okay, so let's start. So we're gonna talk about object-oriented design. Does anybody remember the classic stages of software engineering, the software engineering life cycle? Does anybody remember the classic phases, the ones that you taught in your textbooks? You're lucky I don't have your names. Otherwise I would start calling names. What's your name, by the way? Say it again? Nikki. Do you remember the classic stages of software engineering?
Development, testing, and maintenance.
That is very close, very, very close. It's a great answer. But you're missing one. Anybody know which one she's missing? Say it again. The first one's the requirement specification. The second one is design. Anybody remember that? Software design? So this is the most mysterious part of software engineering, is the software design. And that's exactly what we're going to focus on for the next 3 weeks. The main focus is going to be on design, software design. It's the most mysterious part of software engineering. It's the least well understood part of software engineering, and that's why we're going to talk about it. I happen to think that it's the most important part of software engineering too. I'm probably in the minority on that opinion. But I have a theory that the reason most software engineering projects fail is because of the lack of understanding with respect to design. So we're going to talk about object-oriented design, which is one way to organize your software. Right? Imagine you have a program that's 1 million lines of code. You have to think very, very carefully about how it's organized. Very, very carefully. Otherwise, the project is going to fail. Okay. And also, a little side note, these are the books that we're drawing most of this lecture material on. So these are kind of classic object-oriented design books. So we're going to address some very fundamental questions, and this is a very uncommon. What we're talking about is not covered in a lot of software engineering classes at different universities. Usually you just kind of get spammed with the 5 stages, and you never go into any depth about the design process. So we're going to answer some very fundamental questions that some of you might know some of the answers, but some of you might not. I'm guessing that most people don't know the answers to a lot of these questions. For example, how can we take a software specification and turn it into a design? Right? That's one of the things that's the fundamental question we're going to answer. How can we transition from a design to an implementation? That's another question we're going to answer, or we're going to address. When should we introduce a new object or a new class into our software? Right? Does anybody know the answer to that already? That would be amazing. When should we introduce a new method? Right? I think some of you have thought about that question already. Yeah. Are there any guidelines for writing good classes and methods? So that is something we have talked about so far, but we're going to talk about that more. Which methods belong to which classes? Some of you, like if you're in the advanced stages of software development, you've already started thinking about that question. And how big should a class be, and how should classes and methods be organized? These are the fundamental questions we're going to try to answer in the next 3 weeks or so, or 2.5 weeks really. And when you get to a professional level of software engineering, you're thinking about these questions all the time. Or if you're a good software engineer, you're thinking about these questions all the time, because they're all about organization. How should I organize what I'm doing? How am I going to organize my objects, my classes, my methods, my source code in a logical way? Okay, so what is an object? Right? Very, very fundamental question. You've probably heard the word object a million times by now, at least, hopefully. But maybe nobody has ever tried to define it, right? It's a very basic question. By the way, a bonus, this is a good job interview question. So if you're going for a job interview, you have to be able to answer this question, right? This is a typical software developer job interview question. An object is a set of closely related data and methods that operate on that data. That's the definition I'm proposing. You can find other definitions in your favorite books, but this is, since it's my definition, I like it the best. And if you give this definition at a job interview, you will get that they will approve. Yeah, you'll get that question. An object knows what it is, right? The information about itself. It knows its responsibilities. We're going to talk about responsibilities, by the way, and how to fulfill them, and the tasks that other objects request. It has a role to play in a larger system and knows how to perform that role. And it doesn't have to know anything about anybody else necessarily, unless it's performing some sort of a collaboration. And an object is responsible for information hiding, right? We don't want other objects to have direct access to a given object's information or data, right? Those are also called member variables. When you think of information, that translates into member variables for Java in the Java language. Some of the fundamental concepts of objects that you've already seen, right? Encapsulation, information hiding, message passing, polymorphism, classes and instances and inheritance. You're already familiar with these topics, but you're seeing them again. Does anybody know what it means when you see a theme more than once? Like imagine you're taking a degree like computer science and you see this theme keep popping up. What is that? Does anybody know? Oh, that's the door. It's very loud. Does anybody know what that's a sign of? That's a sign of something. So imagine you see this word polymorphism and you keep seeing it over and over again. That's a sign. What kind of a sign is that? Anybody want to take a guess? It's a strange question, but it's a good question. Anybody want to guess? No Halloween candy? What's your name?
Daniel.
Daniel, what do you think?
Does that mean it's in the exam?
Very good answer. Very good answer. It means that's not what I was thinking. Rainbow drops. It means it's important. So when you see this subject like over and over again, it means it's important. That's why it keeps cropping up. So we want to also consider object capacities or capabilities. So we're going to introduce some terminology here that's related to object-oriented design because this book uses some special terminology. Messages, and object A sends a message to object B, right? That corresponds to a method in Java, right? Object B does X, which may involve returning results, right? That's the return part of the method. The behavior of an object, you hear this term a lot. It's the set of messages recognized by an object, or the methods inside of an object. That's the behavior of that object. You'll hear that term a lot, right? You could hear that in a job interview, maybe. A method, a function performed by an object as a result of a valid message, right? A valid method call. And the signature is the name of the method, the parameters, and the values returned. So sometimes I will say method signature, and it means that first line of a method. The name of the method, the input parameters, and the return values. I'm going to try to go a little bit fast, a compressed version. Classes and instances. Can anybody describe the difference between a class and an instance in their own words? Maybe I remove that slide so you're not reading off of it. What's your name?
Thomas.
Say it again.
All right, Thomas.
Thomas?
Thomas. Thomas.
Thomas, okay, I got it.
Okay.
Class versus instance.
Class is a blueprint. Instance is the final product.
Instance is the final product. Okay, that's an interesting way of formulating it. Any other hold on. Any other formulations? Name? Ella. Is that right, Ella? I have hard here. I'm already like 65 years old, so just speak up.
Yeah, and it's an object is actually an instantiation of the class. The class is the general framework. So an object is when you use the class to create.
That's correct. Yes, very good, Ella. So the class is like the definition of an object. I didn't have to throw actually. I just handed it to you.
Is it like with the car and the tires? So there is a...
You watched the pre-recorded lecture.
Yeah, I did. I did it yesterday at midnight.
Well done. Well done. Yes. Well done. What's your name? Shelsky. Thank you, Shelsky. Thank you. So the class is like the definition, and then the object is the instantiation or that realization of the class into being, so to speak. It's like the creation of that class into an actual or virtual thing. So the analogy I used in the pre-recorded lecture was a tire. I don't know why I used that, but I think I used that because there are 4 tires. That's probably why. But you have to define a tire. You have to come up with a specification for a car tire, right? And then you have to make them. So that specification that says they weigh this much, they have this composition, they have this dimensions, that's the class. That's analogous to a class. And then when you manufacture them, and put them on the car, that's the actual object. So that's classes versus objects. It took me like 50 years to understand the difference. I remember not really understanding the difference when I first saw this. When I remember taking this class and not understanding it immediately, but there wasn't such an amazing analogy either at that time that I just gave you. So often a system needs many copies of a given object, right? And we need to organize the objects of the same type. So a class is a set of objects that share the same behavior, and it's the generic specification of such objects. You can also think of it as a template. I still remember the first time I heard the word template as well. And I was like, template? What's that? It's a specification. Instance, a member of a class, the object itself. Here's a typical class hierarchy. You all are familiar with this by now, I think. So here's a class called figure, and it has this methods draw, and it knows its area and its location. And then we have child classes, polygon, that inherits the draw area. And there's a new responsibility here called vertices, circle, square, and so on, right? So you've all seen this before, so I won't talk about this very long. Does anybody know why we like this class hierarchies? What the advantage that a class hierarchy offers? Is it Ella? Oh my gosh, I can't believe I remembered.
You can reuse the code and you can make that either.
Okay, I'm only giving you two. I'm only giving you two. Yes, code reusability, that's one of the major. And shared behavior is another way of saying that. That's the kind of terminology we're going to use. So we're maximizing code reuse, or we're encouraging code reuse, and we're encouraging shared behavior. You had a complicated name, didn't you?
Chelsea.
Chelsea.
Yeah. So what about, I think it also helps with polymorphism.
That's right.
So
That's
if
right.
you have like a class that is really high hierarchy, it can only like be the basic behavior.
Yes,
And then the class below it can extend this behavior.
that's right. It goes from sort of very general to a little bit more specific. Yes. So let's not spend too much. We're going to come back to class hierarchies because we have a whole lecture just on class hierarchies. So going from specification to design has multiple phases, right? These are the three major phases. The initial exploration phase, where we try to find classes, operations, and collaborations. We try to find them and define them. Then we have a so-called detailed analysis phase, where we build class hierarchies. And then we have a subsystem definition, where we try to put related objects and their responsibilities all together in a system. You can think of that as a package in Java. That's the overview, and it's an iterative process. So once you've got your subsystem identification, you might have to go back to the object definition phase, make some changes, and then repeat the process forever. The initial exploration is identifying classes, identifying responsibilities. So when I say responsibilities, we're going to talk about that in a few minutes. That means methods and the data that those methods operate on. Information, I'm using these terms data and information interchangeably. I'm not making a careful distinction there. So when you see information, you can think data. When you think data, you can think member variables. For example, they should be private, generally speaking, in your favorite programming language. And then we assign responsibilities to classes. So determine how each object collaborates with the other objects to carry out its responsibilities. So here's something that you might find interesting. How would you identify an object, right? You'll never get such an advanced question in a job interview. That would be a good question for the guy giving the interview, say, oh, given a specification, how do you define objects? That would be, but you'd make him angry probably. So imagine you're given a specification. They're often in written form. Classes correspond to nouns. Did everybody notice that already? You may have noticed there's a pattern with class names and object names. They're always nouns. That is an absolutely fundamental rule, and if you look carefully around, you'll hopefully see that rule being followed. If you see that rule not being followed, somebody has made an error. But if you look at the Java API, for example, you'll see that they all follow that rule, right? They all use singular nouns by default, right? So, for example, vertex would not turn into vertices. You would never call a class vertices. You might call the class something like vertex manager or vertex collection or vertex list, but you would never have a class called vertices, right? And you would never have a class called tires. You'd have a class called tire and then tire manager, or tire collection, or tire list, but you'd never have a class called tires. I know some of you have made this mistake in this class. You think, oh my gosh, I can't believe I just called my class tires. Methods correspond to verbs. Has everybody's noticed that already? Hopefully. So vertex draw. So draw is a verb, right? Identify what a class does and do not focus on how a class does its job. Right? That's up to the person who implements that class. Identify the information and the data the class needs to carry out its task and eliminate redundant classes. Okay, and that's what I was already rambling about. Multiplicity corresponds to collections, like a vertex collection. You would never say vertices or tires. You'd explicitly use something like collection, list, manager, or something like that. By the way, at my last software engineering job, so you imagine you start a new job. At some point, you're seeing the source code for the very first time, right? I remember looking at the source code for the very first time at my last software development job, and they weren't following these rules, right? They had some classes named with verbs, and they made this mistake with adding an S from going from singular to plural. Some of the methods were nouns, and I knew within 24 hours I was working on a failing project. I knew it. I could just tell. Bam, these guys don't understand object-oriented design. They're not following coding conventions. This project is failing. You can know immediately and get really excited about that. Does everybody remember the first lecture, where you find out that most software engineering projects fail? The majority fail, actually. So more than 50% of software engineering and IT projects fail, actually.
So I have a question. Why is the S at the end so important, like not to put it? Why is it so important to say vertex instead of vertexes, vertices?
Yeah, there are a few reasons. Vertices, if you call a class vertices, by the way, he asked why is the S, avoiding that S or just the plurality so important? There are a few reasons. One is, if I have a class called vertices, I'm not really sure what it is or what it does. I can take a guess, but it's not very informative. And if you notice the Java API, they never do this. If you call a class vertex collection, then I know immediately what it's doing. And and you have different kinds of collections. You have things like arrays, array lists, vectors, collections. So adding that extra information will tell you a little bit more about what the class actually, how it manages the collection. And I find it also very confusing if you have two classes that only differ by one letter, like, you know, tire and tires. It's like, it's very confusing, actually. It's like, it's a mystery how those two are related to each other. Okay, stage 2 of the overall process is analysis. We examine classes and responsibilities to define if classes share behavior, right? Can one be made a child of the other? That's where this class hierarchy comes in. Can both be made the child of a new abstract class? We're going to look at all of these in detail, by the way, in the next 2.5 weeks. Can we streamline collaborations? In other words, can we make collaborations a little bit more clear, right? Examine classes with widespread collaborations. Maybe they have too many responsibilities, or maybe they're not needed. You can imagine that that topic is closely related to subsystems, right? Not very hard to imagine. And then identifying subsystems. So a set of classes or a set of subsystems that collaborate to fulfill a set of responsibilities. So a heavy collaboration among a set of classes may imply the need for a subsystem. And we're going to talk about subsystems in a special lecture. So a subsystem is a higher level of abstraction than a class. It's just a set of related classes that fulfill a set of related responsibilities. Right, and you won't be asked to create subsystems in the coursework, but you'll ask to create packages, which is pretty much the same thing. It's very, 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 not exactly the same, but very close. Also, during this lectures about object-oriented design, we're going to be using this client-server terminology. So the object-oriented model is a client-server model. You can think of it as a client-server model. So one object requests information or a service from another object. So the object that makes the request is the client, and then the object that fulfills the request is the server. Object collaborations are one way. So one object requests services of another object. The client object requests the service. The server object receives the request and provides the service. And the interaction is defined by a contract. Right, that's, you can think of a method call. Whenever you call a method, right, it's, unless that method is within the class that's calling it, it's a client-server relationship. Okay, and we also mentioned so-called contracts, although we won't be going into contracts at depth. A client and server are roles that objects play. An object can be either a client or a server, and it's usually both. It usually fulfills both roles at some point in time or during some collaboration. And the client-server concepts keep track of the relationship between two objects at any time. And that is why the collaboration is one way, right? And each object can be part of many different contracts or collaborations. Any questions about objects? So that was a kind of accelerated version of the lecture on objects. And you can find the full-length version on Moodle. Right, I did the so-called full-length version of that lecture last year on Moodle. But I thought I would do the condensed version. Question, is it Nikki?
Yeah.
Oh my gosh, I can't believe I'm so bad with names, so bad.
What was messages between objects? I couldn't remember.
A message is just a method call. It's just a method call. So it's the specification of a method name, the input parameters, and then the return values. Okay, I have some Halloween candy left. I think I'm gonna limit to 2. If you have 1, then you only get 1 more. Unless I have a whole bunch of hands. I'll practice my throwing. I'm not very good at it, I can see. Is it Ella? What was the question?
You know, you said the data can only go one way. Can
Yes.
these objects sort of include each other, have instantiations of each other inside each other? If they do it
I think it's
together.
observe the pattern. I mean, the thing you want to do is observe the pattern. So it kind of is like
So if I understood the question correctly, the question is sort of, is it possible to have a 2-way? And yes, it is possible, but you need 2 method calls. That's the idea. So when you have 1 method call or 1 message, the collaboration is 1 way. But if you add a second one that goes back, like imagine I have a class that needs to know the time. The class is called Bob. And so I asked the time class, can you please give me the current time? And then the time class comes back to me and says, Bob, you need to tell me which time zone you're in. Like, and those are 2 methods. That would be a 2-way collaboration. Yeah. Any other questions? Good questions, by the way. I already gave you 2 pieces. Is that right? So I'll if there are some left over, maybe you get a 3rd one at the end. Any other questions? Is the Halloween candy inspiring anybody? Name?
Oliver,
I can't see that far. Oliver.
can you explain that joke?
Say it again?
I don't get a joke.
I didn't hear the
I don't get
question.
the joke in the script.
The context.
Oh, you don't get the joke. Consultic? It's a pun. Consultic. So everybody knows what a tick is, right? And you know what a consultant is, right? So a consultic is somebody that sucks the blood out of the company in the form of cash. Yes. Okay, this is going to be interesting. Everybody cover your heads. Cover your heads, yeah, this is going to be dangerous. Amazing. We need insurance. We need insurance for this class. This is going to be a condensed version of the lecture on responsibilities. I might not finish, but that's not the end of the world. The extended version will be on Moodle. But we just want to make sure we cover the basics. Everybody know what a consultic is now? I could tell a story about a consultant. I won't do it today. Maybe one day. Does everybody know Dilbert, by the way? I hope that you know Dilbert. If you don't know Dilbert now, then get acquainted with Dilbert when you start the real world, because it's really accurate, an accurate depiction of reality. So, class responsibilities. So I'm going to use this term responsibility a lot. That's part of the book, what the book likes to use. There are 2 kinds of class responsibilities: knowledge maintained by an object and actions an object can perform. It is confusing because we're not making a careful distinction between knowledge, information, data, and I think of member variables. We're not making a very careful distinction between those things. That makes it a little bit confusing. But when you see the word knowledge, if you think data and member variables, that's a good thing. That's a good association. That's what I think when I see the word knowledge in this context. Actions an object can perform, those are the methods, right? And now that makes perfect sense because you know all methods are verbs and verbs are actions. So it all fits together. So those are the two kinds of responsibilities, and they should represent the purpose of an object in the system, and they define services provided by an object to the rest of the system or the rest of the software. So information can be returned to a client object. An action object can be performed for a client object. Getters and setters, right? You're all familiar with getters and setters, or what are those called? Accessor methods. And they represent only the publicly available services, so public methods. You never really want to have public data. I won't use the word never, but as a general rule, by default, you don't want public data. You have to have a good reason. Concentrate on what a class does, not how it does it. And that's a good rule of thumb for your group work. You're all in groups and you're doing group work on some group project, right? And you're having discussions about your software and how to develop it, and how you want to go through a design phase, by the way. Don't have arguments about how something gets done. Don't do it. Right, get out this slide. If you get into an argument about how something should be done, be like, oh, just look at slide 17 of Bob's Objects and Responsibilities lectures. Get out that slide. We're not having an argument about how something gets done. Concentrate on what a class does, not how it does it. Anybody want to try to imagine why that could be true? Why that guideline exists? Name? Oh, we got two hands. Where was Alex?
Yeah.
Where are you, Alex? Okay, hiding behind the screen.
It's because in the future, how it's implemented could change based on everything.
Yes, that's a good answer. It's not the one I was thinking of, but it is a good answer. Do you have insurance? Everybody here have insurance? Pretty close. Yes, the how it's done is up to the person that actually implements the class. That's one reason. Another reason is because there are an infinite number of different hows. There are an infinite number of different implementations for the same idea, right? So you could be arguing about how forever, because there are an infinite number of possibilities as to how something can get done. So concentrate on what a class does, then your discussions will be short and constructive. So guidelines for identifying responsibilities. Examine verbs in the requirement specification. So in the first pass of the requirement specification, we looked for nouns, and those corresponded to objects. Then we want to look for verbs in the requirement specification. Those correspond to responsibilities or methods. You can think of them as methods as well. Each active voice verb may indicate a responsibility. Turn passive voice sentences into active voice sentences and have a look if you discover any new responsibilities. Examine information nouns in a requirement specification. These could become a data variable, right, in a class somewhere that we try to find. Information words can imply like how much, how many, how big, those kinds of attributes, any kind of data attribute. And then you perform a system walkthrough, right? That's the imaginary case scenario where you have to imagine using the software, like the first screen of the software. It might say like, it might be a splash screen or something. And then you get the login screen, and then you log in and you have these different possibilities, like the first menu, what are the different menu options, and so on. Has each action been noted, and have responsibilities from each action been identified? And then we have to re-examine our candidate classes, right, that we identified from the identifying candidate objects guidelines, which you've already forgotten, but it's okay. So we re-examine candidate classes. Identifying a class implies at least one responsibility, right? Every class has at least one responsibility. The name of the class may tell you what the responsibilities are. Like time, if you have a class called time, that's a good name because it's pretty clear what the responsibilities are. The statement of a purpose may imply some responsibilities, and the attributes of the class may need to be managed. Right, the time class is going to have like military time versus, I don't know what the other one is called actually. The time zone, the time format, the time, the second specification, do you want sub-seconds or not? And it's going to have like what the calibration is to, which clock is it calibrated to. Right, you can. Those are all implied responsibilities of the time class. Okay, so when we identify responsibilities by highlighting all the verbs in our requirement specification, you can imagine actually getting out a highlighter and highlighting the verbs. We can assign those responsibilities to classes. So examine the context in which the responsibility was identified, and you use the requirement specification as well as class definitions. Usually the classes and the responsibilities will be in the same sentence, right? Because sentences have nouns and verbs, right? The nouns correspond to objects. The responsibilities correspond to verbs. They're usually in the same sentence, so they're usually already associated with each other in the natural language. So we want to distribute system intelligence evenly. So I'm using this word intelligence, which is confusing, but that corresponds to data and the methods that operate on that data, right? State responsibilities as generally as possible. Keep behavior with related information, so keeping the data, special data, and the methods that operate on that data in the same class, right? That's a fundamental lesson that you already know about. Keep information about one thing in one place. So the time, it's not a very exciting example, I know, but the time is only kept in the time class and nowhere else. Anybody know the reason why that's a guideline? Keep information about one thing in one place. That's a really good name. Matt?
Yeah. So that way you don't need, it can be difficult to, if you've got two variables doing the same thing, then you need to keep them the same. Or
Exactly.
cause errors.
To make sure that everything is consistent. That's right, for consistency. Should I just run up the stairs? Love that, Matt. Rolling is a little bit more fun. Okay, share responsibilities among related objects. How are we doing here? Okay, we're gonna run out of time, but no pun intended. But anyways, it's okay. It's not the end of the world. System and class intelligence. So intelligence, you can think of intelligence as data and the methods that operate on that data. And yeah, I'm using it very similar to knowledge and information, just to confuse you. So system intelligence is what the system knows, what actions the system can perform, and the impact the system has on other systems. Class intelligence is determined by two major components: what service it provides and what services does it use or need. So it's collaborations. And I know Pierre also talked about this already, and I don't know if he used these terms exactly, but Certainly you've seen these ideas already. So there's a server view of intelligence, what the class knows and provides to clients and what actions it can perform, right? Every object, generally speaking, every object acts as both a server and a client at different points in the software. The client view of intelligence is how many other classes do we collaborate with, right? And how much does it need to know about those other classes? And some examples are collection objects. They have low intelligence, right? Arrays and sets, for example, they have little effect even on objects stored in them. And then I'm using this drawing editor as an example. This comes up over and over again. Pierre likes to use that zoo example, like he mentions the zoo program. I like to mention the drawing editor program. You all used a drawing editor program in 2 labs ago. What was that program called again? Visual Paradigm, is that right? Yes. You already got 2 pieces of candy, right?
It's fine.
No, you didn't get it. Nikki got them. What was your name?
Francesca.
Francesca, yes, Visual Paradigm. Sorry, I got it. I didn't see it, not last time. Put your helmet on. Yes, Visual Paradigm. That's a drawing editor. So when I say this phrase drawing editor, it means a program that you draw figures in. Right? The drawing editor class has a lot of intelligence because it has to know about a lot of other objects. Right? It has to know about the GUI, like initializing the GUI, getting the input from the user, all those mouse clicks and the mouse position. It has to know about the canvas that is drawn on and all that. So it's a very intelligent class. The CIA, if you had one object and it had every method and every member variable in it, it would be centralized intelligence, right? That's the extreme end of centralized intelligence. There is an advantage to having a program that's just got a start and a finish, and it's 10,000 lines long. That you can find such examples, they do exist. There is an advantage to this, though. There are more disadvantages than advantages. But does anybody know what the advantage to that a program that starts at the top, it's got one method called main, and that's the only method, and then it ends 10,000 lines later. There is an advantage. Anybody think of the advantage? Name?
B.
Say it again.
B.
B.
Is it the idea that you know that everything's going to be in that one function? All of your problems are going to be in that one function. You have to go looking through all the different classes to find out issues.
I suppose that's one advantage. You know that the problems are all going to be in that one function. Could anybody think of another advantage? Are you ready, Ray? Name?
Just talk about advantages.
Say it again.
Don't worry about my name.
Okay, I won't worry about your name. I haven't forgotten it anyways.
So basically, one method is that much long, we can make sure we go very efficient. We can have current functions frequently. Can you just go for a sequence?
That I would say that's debatable. If I understood the answer, you said it could be more efficient. I would say that's debatable, but that's not. I would say, yeah, we could have a big debate about that, whether that's correct or not. But you still get some candy anyways, by the way. I'm doing well.
Could you do the message passing? one level by one level to one level, please. No, I can't cut it.
You're making me run up the stairs. There's another answer over here. Question, what's your name?
Daniel.
Daniel.
I mean, it says up there, but the
Does it
control
say it up
flow-
there? Did I give the answer up already on the?
Yeah.
Yes, that's right. The answer's on the slide.
So if let's pretend I wasn't reading,
Yeah.
I would say the control flow is pretty obvious because
Exactly. The flow of control is easier to follow. That's right. That's the answer. And it's good when you look at the slides too. It's easier to follow the flow of the program. Or sometimes we call that the flow of control or the flow of information. It goes from top to bottom, line by line. That's an advantage. This is the big disadvantage with object-oriented methodology. This is the disadvantage. Not many people will talk about that. But it's a disadvantage when you have an object-oriented program to figure out the flow of control and how the information is flowing and which objects collaborate with other objects and what that system looks like. That's a disadvantage. And you will discover that disadvantage as soon as the coursework is released. Because you download this game, it's got a bunch of different objects, and your job is to try to start understanding it. And it's like, oh, wow, how do I do this? How do I figure out the flow of control, how this program works? And it's really difficult if you have 1,000 objects, for example. It's really difficult. There are some, we don't use one method anymore and one class, right? The disadvantage is it hardwires system behavior, right? It makes it difficult to change, actually. Because if you try to change line 2001, you have no idea if it's going to affect line 9115 or whatever. That you don't change it. If a method is too long, you never change it, actually. You never ever change it because you're afraid that you'll break it and you don't want to be responsible for breaking it. And this happens all the time in industry, all the time. You see a method that's 2,000 lines long, it was checked in using version control 20 years ago, and nobody has ever touched it because they're afraid if they touch it or check it out that they will be responsible for breaking it and they can't debug it anymore. It really happens. One of my recent graduates said he has code from the 1980s that they're still using. Okay, I think we're out of time. Is there another? There's probably another class where you anyways. So please watch the rest of the lecture. We were going to talk about distributed intelligence. Pierre has mentioned this. This is the goal of object-oriented methodology, is to distribute the intelligence of the software evenly. And then we have some more details about responsibilities, keeping information about one thing in one place, and so on. And we'll talk about class. We have a special class on class relationships, no pun intended, coming anyway. So thanks, everybody.